Interesting math project. I chose Diophantus's Arithmetica. So basically, we're going to start out with who he was. He's from Alexandria, and he's basically the mathematician in the third century. No one really knows much information about him. We can't find much about his age or anything or his the time he lived, his family. Not much is known. He's considered the father of algebra and was the first mathematician to use algebraic notation and symbolism, and we'll see that through Arithmetica. He wrote several different books apart from Arithmetica, but none of them are as popular. Some of them were Moriastica, Porus Mata, and one on polygons, but of course Arithmetica was the most popular because it just was different, a different way to represent algebra, and it inspired the rebirth of the number theory. Just a fun fact on the bottom. That's the problem. That's the problem on his tomb that can show how he solved his age. Yeah, just fun fact. So the introduction to the book, basically, it was written to his friend almost as a textbook to solve math problems. And basically, the book is like books. So there's 13 books in the series, and or in the series within that consist. And they're just a collection of problems and then the solutions that he would solve. The equations and those are called Diophantine equations, and the analysis of them is the Diophantine analysis. Most of the problems lead to quadratic equations, and basically we'll look at this more, but just general construction for how the problems are written. This is just a sample page of it, of course, translated from from Arabic, to English. So the books get harder as they go. So as you look at book one is just more simple, algebraic based, like the first degree. But when you go to books 8 and 9, you get to those more difficult problems. Yeah. So as I said, he was famous for symbols, and he came up with this representation of symbols to represent x squared and so on, all the way up to x6. You can notice a pattern between x squared and x to the fourth and x to the third and x to the sixth because they're twice. There's just ways how he wrote the problems themselves. He never used signs for addition, multiplication, rarely even division. And he just represented them with coefficients or the m with the little circle on top. That's just a chart. Okay, so another point of his book was determinate and indeterminate equations, and if you don't know, determinate equations have one unique solution, and of course indeterminate do not. So Diophantus, as we said, he created the Diophantine equation, and what that equation is they're indeterminate but have solutions that are integers. And we'll see a lot of those in his book. Basically, this one, all of his entire book is only positive solutions. So in this case, you would think x to be -4, right? But he called it absurd because there was no way that 4 could be there because it had to be a number greater for x to be positive. So how he solved the problems was he would never look at it more generally. He would just pick a specific scenario with specific numbers and then solve the problem. So if you look at the problem, in modern day, what we would do is we would just use A and B and C to represent variables to try to solve for how we would get x. What he did was he would take specific numbers as that specific instance, and then he would write down the necessary condition and then solve it from there. The importance of this is his book basically revolutionized how people saw algebra. It was the modern way of algebra, and it helped out many future mathematicians, including Fermat. If you look at the equation on the bottom, if you take n as 2, right, it's x squared plus y squared equals z squared. That's the normal Pythagorean theorem. But Fermat was able to create this theory from Arithmetica that if you took a number greater than 2, it would not result in whole number solutions. So basically, the book helped create mathematicians, the interest in algebra and mathematicians to come. So basically, just a quiz. He was known as the father of algebra. Of course, before that, though, there were many, the Babylonians who studied that. How many books comprise? Again, 13. Only 9 of them are, or not 9, only 10 of them are found, so 3 of them are missing. True or false, diaphantus only use positive solutions? That's true. Thank you so much for watching.